All right, let's jump right in. Today, we're going to talk about the science that, basically writes the rule book for our entire physical world. Seriously. From the air we breathe to the phone in your hand, it all comes down to one thing: chemistry.
So let me ask you something. Just think about your day so far. That smartphone in your pocket, maybe some medicine you took this morning, and yeah, even the lunch you're planning to have. What do they all have in common? Seems random, right? But what single invisible force connects every single one of them?
You guessed it, the answer is chemistry. It really is the engine of progress, just hiding in plain sight. It's woven into the very fabric of our daily lives, from the totally mundane stuff to the absolutely miraculous.
And that brings us right to our first big idea here. See, chemistry isn't just one science among a bunch of others. Nope, it holds this really unique position. It's often called the central science.
Okay, so what is chemistry really? I mean, the formal definition is that it's the branch of science that studies matter. You know, what stuff is made of, how it's structured, and all the changes it goes through. Basically, it's the science of, well, stuff.
So, why central science? What does that even mean? Well, think of it like this. It's the ultimate connector. It's the bridge. It takes the super fundamental laws of physics, all that stuff about atoms and energy, and uses them to explain the really complex systems we see in, say, biology, like how our own bodies work, or in geology, like how mountains and minerals form. It's kind of like the universal translator that lets all the other sciences talk to each other.
Okay, to really see how this all works in the real world, let's follow a story. We're going to see how a chemist can be a lot like a detective, using this powerful toolkit to solve a really puzzling environmental mystery. So meet our hero, Dr. Eris Thorne. She's this brilliant environmental chemist, and one day she discovers that a local waterway, Crimson Creek, is in big trouble. The waters turn this weird, deep reddish color, and all the plants along the banks are dying off. Her investigation doesn't start in some sterile lab. No, it starts right here, at the scene of the crime, so to speak.
And what's her secret weapon? It's the scientific method. This is the step-by-step playbook all scientists use to get from a question to a real solid answer. Dr. Thorne sees the dying creek. That's her observation. And it leads to a huge question: what is causing this? So let's watch how she uses these exact steps to crack the case.
All right, next up is the hypothesis. And let's be clear, this is not just a wild guess. It's a smart, educated, and most importantly, testable explanation. She knows there's an old factory upstream, so she proposes her theory. Heavy metal contaminants from the factory's industrial waste are leaching into the water. See how specific that is? That gives her a clear target for her investigation.
So, after all the careful experimentation, collecting water and soil samples, running tests back at the lab, the verdict is in. And boom! Her analysis reveals dangerously high concentrations of a specific heavy metal, but only downstream from the factory. The water upstream is clean. The evidence is clear, and it confirms her hypothesis. Case closed. And it wasn't solved by an opinion, but by cold, hard, reproducible data.
Now, what Dr. Thorne did, that falls under a specific field called analytical chemistry, but that's just one piece of a much, much bigger puzzle. The whole field is broken down into different branches, and you can think of each one as a unique lens for looking at the world.
So here are the 5 big ones. You've got organic chemistry, which is all about carbon, the literal backbone of life. An organic chemist might study how those pollutants from the creek get into the plants and animals. Then there's inorganic chemistry, which is basically everything else, like the actual heavy metals Dr. Thorne found. A biochemist would zoom in even further, looking at exactly how those metals are messing up the cells of the fish. Analytical chemistry, that's Dr. Thorne's specialty, is all about identifying what's there and how much. And finally, physical chemistry uses the laws of physics to figure out the why, like why are those metals even dissolving in the water to begin with?
So this incredible power to understand and literally manipulate matter has completely reshaped our world. I mean, completely. But like any powerful tool, it's a double-edged sword, right? It has the potential for so much good, but also for some serious harm.
I mean, on one hand, you have the promise. Life-saving drugs, amazing new materials like plastics and semiconductors, the fertilizers that literally feed billions of people. But on the other hand, you've got the peril. Environmental pollution, just like we saw in Crimson Creek, health hazards from toxic chemicals, the list goes on. It's the exact same power, but with 2 totally different faces.
So, what's the solution? How do we manage all this risk? Well, the scientific community's answer is something called green chemistry. And this isn't just about cleaning up messes after the fact. No, it's a huge shift in thinking. It's all about designing smarter, safer processes right from the start to prevent pollution before it even happens. This is really the ethical future of the entire field.
All right, so let's shift gears a little. When you hear the word chemist, what do you picture? Probably someone in a lab coat, right? Surrounded by beakers. But the skills you get from chemistry, they open doors to a surprisingly huge range of careers you might never expect.
So what can you actually do with a background in chemistry? I mean, for real, what do these career paths look like? Well, the answer is probably going to surprise you.
Of course, you've got your lab researchers, that's a given. But what about a forensic scientist analyzing evidence at a crime scene? Or a patent agent blending science and law to protect new inventions? How about an environmental consultant or a food and drug inspector? You could even be a quant on Wall Street, using those insane problem-solving skills to analyze financial markets. The possibilities are, wow, they're just incredibly broad.
So why? What is it about a chemistry background that's so valuable? It's not about memorizing the periodic table, I'll tell you that. It's about the rigorous training you get in analytical reasoning, in quantitative problem solving, and in just being precise. You learn how to look at a super complex problem, break it down into smaller pieces, and then solve it with actual data. That skill set is pure gold, and it's in high demand absolutely everywhere.
So, where does that leave us? At the end of the day, we've seen that chemistry is the central science, right? It's a powerful detective's tool, but it's also that double-edged sword that demands we be responsible. It is the absolute foundation for our health, our technology, our entire economy. So I'll leave you with this question. Now that you have this new perspective on chemistry, how is that going to change the way you look at the world's biggest challenges?